So just a few quick questions to begin with. This is a talk on ngRx. Who's heard of ngRx before? So like half. Who's actually used ngRx? Oh, maybe like 20%. Okay. So as I was preparing for this talk, I was practicing with my 11-year-old daughter. And after about a minute, she goes, Asim, do you have any jokes? I went, it's a technical conference. These are professionals. They're not here to hear me joke. She goes, Asim, I think you really need some jokes. I went, I don't know. Do you have an idea? And she goes, she thinks about it for a second, and she goes, can you, like, make a unicorn go pop on the screen? I thought, no, I can't. And I thought, yeah, I can. Okay. But, you know, now I use this application called Keynote, which has a whole bunch of animations. Now she discovered these animations, so she started playing around with them. And then she discovered kind of the ultimate animation in Keynote, which is Anvil. Okay? When you really, really, really want to make a point with Keynote, you use Anvil. So there's no real kind of, to cut a long story short, this isn't in any way related to the talk in ngRx. I just kind of was a bit excited because this is the first time my daughter's ever shown any interest in anything that I've ever done. So I let her go wild on the presentation. And there's probably just a lot more unicorns and anvil effects than you're used to seeing in a technical presentation. So I just want to give you that little caveat. Okay, so this is going to be a talk on ngRx. If I'm in front of the screen and you can't see, just tell me to move. Anvil. So Angular, you can think of Angular like the architecture of your house. And the way to think of ngRx is, I like to say, to describe it as the interior design of your house. Okay. Okay. So how is this going to be structured? What I'm going to talk about? Well, I'm first going to talk about the history, the family, the lineage of ngRx. So it's part of a family of similar products that have occurred over the last couple of years. Oh, I need to see the screen. Oh, I think the clicker's died. Connection lost. Okay, let's do the hardcore way. But I believe that programming with ngRx, the big part of programming with ngRx, or learning how to program with ngRx, is the paradigm shift in how you need to think about programming. It's such a different way from how we've been taught or how we've used in the past that getting that mental model is the hardest part. And given that I've only got half an hour with you guys, rather than showing you a bunch of functions, which I could do, what I want you to walk out of here is actually just a good idea of, or a good mental model of what ngRx is, what it's good for, what problems is it solving, kind of how it works. So the bulk of this talk is just going to be a whole load of theory. I'm going to explain a lot of it. No, it's okay. I'll use it. It's fine, yeah. So the bulk of this talk is going to be just a lot of theory, and just through a bunch of animations and unicorns, I'm going to show you how ngRx works. But at the end, I'm going to kind of pull it all together with just a really short code example, a very, very, very short one that's hopefully going to pull all those theoretical threads together. So who am I? So my name's Asim. I run a site called Codecraft, which she made me do that animation as well. You can find me on Twitter @Joache, or I'm old, so you can email me as well. And a big thing about me, or something I'm quite proud of, is last year I wrote a book on Angular 2, got Angular 2 from theory to practice, and was funded through some very generous backers on Kickstarter. So it's absolutely free. You can find it on Amazon, Kindle, Amazon iBooks, or if you go to my website, you can find it there as well. So go wild. So why do you care? Why are you here? Why are you listening to me? So I'm going to just list a bunch of reasons right now why you should be interested in ngRx. And then throughout this talk and at the end, I'm going to come back to these reasons. Okay? So ngRx makes your applications easier to reason about. What do I mean by reason? And my definition of reason is the time it takes for you to load an application into your mind or a piece of functionality. And then the way I think about programming is then I kind of fly around this little world in my mind and I'm in the zone. So the easier an application is to reason about, I believe, makes you more able to be a productive developer because you can get it loaded up in your head faster. And that's what ngRx lets you do. It lets you build an application that's easier to reason about. It also makes applications easier to test and also easier to debug. And I'll go through this again later on. I'll prove this later on. So as I said, we're first going to talk about a little bit of history. You might have heard of a bunch of other words out there. I just want to make sure you understand where ngRx fits with all of that. So in 2014, first there was Flux, which released by the Facebook team, and it's mainly used in React, although you could use it in other frameworks as well. Then in 2015, a successor came along, which probably everybody's heard of, called Redux. And again, it's kind of primarily used by the React peoples, but we could still use that in Angular as well with ngRedux. Okay? But then in 2016, we got, we got ngRx. So ngRx is basically not just like a wrapper of Redux for Angular. It's a re-implementation of the core principles and paradigms and concepts in a more Angular way. The hint is in the name, Rx. So ngRx is based off RxJS. Angular 2 is based off RxJS. So it just fits a lot nicer with the Angular framework. And it also has a better, or fits in nicer with the dependency injection framework as well. Okay. Was there a bounce? Okay. So how would you describe what we're talking about? So it's Flux, Redux, ngRx. This is what we would describe as a pattern for handling state in your application. Okay. One thing about me, I kind of don't make any assumptions on knowledge. So what is state? Okay. So this you can just imagine as kind of different parts of your application, be them classes, modules, whatever, different functional units. Okay. And sprinkled around our code are basically state variables, just variables. So they can be integers, numbers, strings, objects, arrays, but around all of our code, we just got all these variables stuck all over the place. The current value of all of those variables at any point in time is what I call state, the state of your application. So what's an application then? And kind of what I'm trying to get through here is more specifically, what do we as developers, what do we do when we program? So here, the green things are events, the red things are functions, and the blue things are their state variables. So what I consider an application is something that responds to events. So event can be time-based or user interaction-based or network-based, but essentially something external to the application. Okay. So what we might have is like an event gets triggered, which then calls a function, and then in our application, we then might read a state variable in the function. We then might write to a state variable, and then call another function, which then triggers another event, which then calls another function, which then saves a bunch of state variables, which then triggers another event, which then calls another function, and finally changes some other state variable. This might be a Boolean, which you change from false to true, and if it's Angular, this might trigger showing a menu or a sidebar or something like that. So, pretty complicated stuff, right? I mean, this is why we get paid the big bucks. We sit down, we have to figure out how to connect all these dots together to make a Boolean to true to show a sidebar. And you know, it's hard enough when we're writing our own code. I mean, trying to understand what we're doing ourselves. But like 99% of developers are in jobs where they're sitting down and working on somebody else's code, or the code that somebody else wrote. Okay, so you have to walk in, and you have to understand what the hell's going on in an application, right? You have to understand all this stuff. Then we kind of have onboarding time. We assume it takes like 6 months to onboard somebody onto your application. But essentially, this is what we do. So that's what a traditional application looks like. What does an ngRx application look like? Oh, sorry. So as a traditional application, what does an ngRx application look like? Now don't look at me. Look at the screen, okay? And be prepared. Oh, yeah. Yeah. If you take nothing away from this conference, just take away the fact that I can do amazing animations. So what just happened here? So you saw we had like all these state variables and a couple of functions just moved over into one place. And that's what we're really doing with ngRx. We move all of our state in our application into one place. Now it's literally one object. Literally one object, okay? And not only our state, but our functions which manipulate state, we move them together into one place as well. So if you look in one of my ngRx projects, I actually have a folder called state. Very unimaginative, I know. I have a folder called state, and inside there is all of my state, my logic to manipulate state, which is really my business logic for my application. Now, I might have other little bits of state variables all over the place in my application, but they're typically like UI variables, like a Boolean, which if true shows a sidebar. That's not part of your core logic. You don't need that. But your main business logic and your state and your state functions, you stick in one place, okay? And this is why I alluded to at the start. This is what makes, this is what makes your application easier to reason about, because everything is in one place, okay? And we call that, what I just described, we call that the store, okay, the ngRx store. That's kind of the one thing that contains all of that data. So then the question is, how do we get state from the store? Okay, so I've got a simple example here. This is a view. This is probably just like a basic Angular 2 component somewhere in the application. This is our store. Okay, the view needs some data from the store, okay? Now, we don't just parse this entire object. Remember I said all the states in one place, one object. We don't just parse that entire object into our component and go wild, like pick whatever you want out of it. The component just wants to know like one tiny part of that data. We call it slicing. So we get a slice of that data, okay? Now, how we do that is we use the function. I might have to duck down for this. We use this, store.select. So store is a service that we inject into our component. Select is a function which lets us slice an individual node from our store into our view. And we tend just to parse it something now. I'm parsing a string because I've set it up so that this node is identified by this string. But that's basically what we're doing, where we're getting a slice of that data and passing it through. But since this is Angular, and since ngRx and Angular are based off of RxJS, we don't just pass a snapshot, we're actually returning an observable. Okay? So now, if in the future your state ever changes, the observable kicks in and your view gets notified automatically. And for me, this is my first kind of mind-blowing moment with ngRx. Because I realized that before I had all these state variables, consider them static, just all over the place in my application. Now, all of your state in your application is an observable. You can listen for any changes to any state variable in your application. So you can almost think of it like in Angular 1 world, scope.watch is the default here. So it's pretty amazing. And once you get your head around that, you start realizing that you can code up your applications a lot differently. Okay? So that's how we get state into a view from our store. How do we change state? Now, we can't change state in the normal way. You can't just go like store.object.mood.foo is equal to 1. We can't just do that anymore. There's a lot more red tape involved. And in fact, we have like 3 actors. We have something called, well, the state itself. We've got something else called an action. And we've got something called a reducer. So state is a state itself. Action is something, usually you can have it as a string, like a unique string which uniquely identifies this action in your entire application. And a reducer is what we call a pure function. Okay? So a reducer takes as input the state, the action, figures out how to apply the action to the state, creates a copy of the state, and returns that back into the store. It's a little bit abstract, isn't it? So let me just stick a couple of numbers in there and hopefully be a bit clearer. So state, for example, could just be the number 0. A number, and it starts off as 0. Action could just be the string add. And our reducer is just a function which goes, oh, if the action is add, I just add 1 to the number and return that back out. Just like that. Okay? So I used a word just now. I said the reducers are pure functions. Who here reckons that they could explain to me what a pure function is? Okay, not that many. But don't worry for the rest of you. I'm pretty sure after 3 minutes you're going to be able to explain pure functions to everybody else as well. So what is a pure function? So it's a term from functional programming. And it means a function that doesn't do anything other than read from its arguments, return something, or call other pure functions. Okay? So if a function does anything other than read a value from its argument list, call anything other than a pure function, or return something, then it's called an impure function. I'm sorry, guys, if you haven't been doing functional programming, you've been writing impure functions. Okay? And anything else it does other than these 3 things is what we call a side effect. Okay? Even something as innocent as reading a global variable from your function. If you do that, that's a side effect. Okay, so there are many reasons for writing things as pure functions. And one of the reasons I think that I've discovered is quite powerful from the ngRx space anyway, is that side effects are the thing that makes testing really, really, really hard. And pure functions make testing incredibly easy. So I'm going to show you with a couple of examples. Just take a sip of water. So this is an impure function. So we've just got this function increment. It's it's reading this variable that's outside of itself called count, and it's just incrementing it. And it's specific, it's not returning anything. If you see a function that isn't returning anything, it's guaranteed to be an impure function, right? So this is an impure function. The same function written in a pure way is this. So we've got the same function increment. We're passing in the count. It's passing into it. And we're incrementing internally and returning it back out. Okay, it's got no external dependencies going on. So how do we test an impure function? Okay, so testing impure functions is really hard. We need to know the internal workings of an impure function in order to be able to test them. Okay, we can't treat it as a black box. So if I want to test the function increment, I need to know that increment depends on this variable called count. I need to know this. I then need to know that the side effect of calling increment is to change the value of the count variable. So my testing is really hard. This is why we use things like spies. Who's used spies in Jasmine? Okay, this is the reason spies exist, is because we're using impure functions. Okay, we have to set something up using a spy because it's got a side effect, it's reading some variable, and we go, oh, before I call my function, make sure that this other thing that it depends on returns a specific value so my function passes. Okay? This is what we have before each, where we kind of spend ages trying to make sure everything in the universe is exactly right, so that when we call a function, it's going to pass, right? This is why we have this stuff. But testing pure functions is super, super easy. This is it. You just pass in arguments. Remember, a pure function can't do anything other than read stuff that's passed into it. You pass in arguments, and only thing it can do is return values. So if you're looking at, when you write your test cases for stuff like ngRx, it's just this. You don't have spies. You don't have, well, you might need spies here and there for other things, but specifically if you reduce the functions, you don't have spies. You don't have before eaches. You just have like a function with just loads of these things written in it. And that's it. Super simple. So that's why using ngRx makes your applications easier to test. So I've got a quick demo here. So this is the code I was going to show you. So hopefully, oops, I should have tested this, I suppose. Exit presentation mode. Oh dear. Okay, and zoom. Okay, so this is some code, which I'm not supposed to show you yet. Exit full screen, here we go. And this is the application. So hopefully you can all see it. I can't see it. Hopefully you guys can. Okay. It's gone off the screen, hasn't it? Okay, here we go. So this is a super, super basic ngRx application. You can't really get much simpler than this. Okay, guess what it does? Click plus, goes up, minus, goes down, goes negative. And you can hit reset, okay? So I want to show you the code for this function. So we've got, this is the, can you all see this? Just about? Okay, this is the component for this function. So you can see here we've got the plus, minus, and reset buttons. And they call increment, decrement, and reset. But then if we look in the constructor, you can see here I'm passing in the store, I'm injecting the store. And I'm calling that function that's called store.select. So I'm saying, from the store, give me the counter. And you can see here, I'm not just getting a number, I'm getting an observable, which I'm storing on a value here. And I'm using something called the async pipe to display it on the screen. Okay, so the store is returning an observable of the number. And then you can see if I press the plus button, I'm calling increment. And what's increment doing is it's sending one of those action things. Remember, I told you to change state, we need to send an action and have a reducer. So these are the actions that we're sending out. So that's the component. What does sugar? What does? God, it's good yoga, this. Okay, here we go. So this is just the basic reduce that we've got here. So you can see you pass in a state, you pass in an action. If the action was increment, I just increase them by 1. Decrement, I decrement by 1. And the other one, I return 0. That's a basic reducer. And then, my God. And then the only other thing I wanted to show you was the app module. So you can see here, all I'm doing to kind of set it up really is we've got store module, so ngRx store at the top. And I'm doing store module.provide store, and I'm passing in the reducer. Okay? So the other thing I'm doing here is I'm pointing to this thing called store devtools module. And I'm adding in basically some really cool debug information as well, which lets us do something really powerful. That's the last thing I want to show you. But it's a different way of debugging ngRx applications, or even Redux applications as well. And it's using something called the time travel debugger. So the title's Redux, but it's still the same tool we can use in Angular. In ngRx, sorry. And then this is basically just another way of debugging your application. So if you look at the top, look here when I click on some of the buttons. So you see I click plus, and we can see here the action that was sent. And not only that, I don't know if you can see that it tells us that the state changed from 0 to 1. So as we're going through our application, as we're using it, it's storing the history of all of the actions that we're doing. Okay? And then what we can do, if we wanted to, oh sugar, is we can actually play them back. Yeah? So imagine developing, as you're developing and trying out your application, you can then go, oh, what just happened? Oh shit. And you can start playing back your actions as they come along. Then you can do some other more interesting things, which is, for instance, you can do these what-if scenarios. You can say, well, what if this one didn't get sent and this one didn't get sent? It will then rerun the application, all the actions through, and show you what your application would have looked like if those, not events, sorry, actions hadn't been sent. And then come back here. And so that's coming back to the slide from before. Using ngRx makes your applications easier to reason about because all of your state is in one place, okay? And all of your logic that manipulates state is in one place. It makes it easy to test because all those functions, all your business logic that now manipulates state are pure reducer functions. And as I showed you, testing with pure functions is super, super easy. And it also makes it easy to debug because of this kind of predictable way that actions are organized in your application using things like the time travel debugger. And there's a bunch of other things I haven't even had time to mention, so it actually makes your application faster as well with things like immutable state and on-push change detection. But if you want to ask me about that kind of stuff, you can ask me afterwards, because this is the end of the talk. And as was mentioned before, I don't think we actually have time for questions here, but if you want to ask me some questions, I'm going to be the AMA section in the corner. But if you want to follow me, you can follow me, or you can ask me questions. You can ask me questions on Twitter @Joik. Thank you very much.